and
Yes,
I'll put it in present mode. Can you see that?
that's good enough. I
Good.
think,
All right.
yeah, it's
All right.
big.
Well, I'll do it in that mode. I'm this is just a reference slide. I'm a retired neuroscientist, but I started out in systems science and cybernetics as a graduate student at SUNY Binghamton in the 80s. And in the 80s, I developed a taxonomy of different kinds of percept action systems. And much that I have to say will dovetail with what Fraser said. That you can have, your typical computer that's getting symbolic inputs from human users is prisoner to its inputs. The human user specifies the internal state, you run the computation, there's an output state, and the human user interprets the meaning of that output state in terms of actions that they're going to take. And you can have robotic systems that are coupled to the outside world, the material world, via sensors and effectors, such that now the internal states of the device have a definite linkage to the external world, the material world. They have external semantics that are not dependent on what the user thinks the tokens mean. The taxonomy went into various ways that you could have adaptive systems contingent that adjust the organization of the computational part contingent on performance. And those are basically trainable machines. And you can also have machines that build their own components, build new sensors and effectors, and thereby come up with emergent functions. So if we think about most of the AIs that we're going to talk about are in the category of trainable machines, like deep learning, convolution machines. And they're trainable machines without sensors or effectors and operating on pre-encoded data. So the human being is the critical link here in terms of providing the input data, the training sets, and giving feedback regarding performance, and interpreting the output decisions and take corresponding actions. This is what Fraser said in so many other words. So all purely computational machines are prisoners of their inputs, and we normally choose for them what are their inputs and what to do with their outputs. But animals and robots can have some autonomy vis-a-vis their inputs, and they can choose what to sense. They are grounded. Their symbols are grounded to things going on in the outside world, the effects of their actions. So, to simplify this, one can think about purposive percept coordination action systems. You have a percept action loop, and then modulating that percept action loop is also an evaluative decision loop about what goals to pursue, and then how to orchestrate the system in order to best pursue those goals. So evaluating which actions are feasible and which goals are most pressing. Now, this is my sort of high-level functional model of minds and brains, the processes involved. And it's more than just goal-seeking behavior. There are also other kinds of processes going on, like goal competition and emotional dynamics. The basal ganglia striatum is involved in action switching and attention, orchestrating the sensory motor systems to be able to carry out whatever goal that it is you are. So my main point is that these kinds of systems in communication with their environments are fundamentally different in many respects from the kinds of informational systems that operate exclusively within symbolic realms, like chatbots, or sort of maybe the extreme, where you have, the assembled corpora of symbolically encoded, lexical communications that are encoded in these symbolic tokens. And large language models are derived from those, and they're once they're derived, they're fixed models. They're not really adaptive unless you have a lot of money and a lot of power in some domain. And then there's also tweaking going on, which is largely hidden, where people are training the machines to respond appropriately given particular conversational contexts and queries. But the human beings are the ones again proposing inputs to these machines and getting the outputs, and they are the ones that are interpreting and evaluating the machine productions, vis-a-vis their own purposes. And then the human beings go out into the world and muck about and do whatever they're going to do on the basis of that. Now, in my thinking, things we need to worry about are of two kinds. And there are three kinds of systems. There are systems that operate primarily in the material world. Animals, humans, robots are acting in the material world. That's our primary, unless you're online 24 hours a day, you're interacting with the material world, and you're interacting with other human actors who are embedded in the material world, and robots share this kind of milieu. Both animals and robots have material actions and knock-on effects in the material world. The second kinds of systems are systems that are one step removed from the material world, that are analyzing mostly signals that are coming from the material world, like deep learning systems for speech recognition or image classification, or convolutional networks where you're analyzing time series signals and images and image sequences. And the third are systems that operate exclusively within symbolic realms, like the chatbots, ChatGPT, and those are rapidly evolving because there's enormous economic, there's an enormous engineering effort going on to improve those. So the gist of my worries are, although they're becoming better at mimicking human behavior and can outperform humans on many tasks. I worked on protein folding back as a graduate student in the 80s, and we did 5 proteins. And that was more than anyone else in the field was doing at the time. So it's just utterly amazing what these AI systems can do. However, they're still very far from perceiving and thinking like human beings. And I must say, I'm going to say this over and over again, how the brain works and how the mind works in minds of animals work is not settled science. We really don't understand what are the signals of the system in the brain at high stations in the brain. We understand pretty well what's going on, say, at the beginning of processing, like in the auditory nerve or in the retina. But once you get to the cortical levels and supracortical levels and then loops, things get very murky very fast. So much of the cachet and fear of AI comes from the mistaken beliefs that AI systems operate somewhat like human brains because they can produce grammatical, fairly coherent sounding answers, descriptions, and conversations in natural language. They sound like, human beings. If you don't pay much attention, they can pass the Turing test. You can think that you're interacting with a human being when you're not. And that opens the door for deception, fraud, impersonation, and all sorts of malevolent and criminal acts. So I think most of the AI paranoia assumes that the AIs are much more powerful than they are, and that they understand more than what they actually do. And I think most of this comes from their facility with imitating human language, but also accessing relevant data. When you query about a specific area, if they had that area in their training set, you know, and it's a decent curated data set with not a lot of crap and hallucinations in it and random comments, then you're going to get back something that sounds pretty boilerplate and pretty reasonable. So the things I think, so we need to worry about the systems that operate exclusively within symbolic realms, because they can change people's minds. They can make people go out and buy stock or sell stock or go to war even, perhaps. But mostly I worry about autonomous robots that actually have can act directly on the physical world. And we need to avoid delegating to them decisions with possible dangerous and destructive material consequences, like automated warfare, you know, and nuclear war, you know, the buttons on the nuclear triggers, or autonomous vehicles that can kill people. So we need to keep humans in the loop, and generally not always, the more eyes on the problem and overseeing what they are doing, the better. You know, I believe in democracy on a very fundamental level. So I have a bunch of very, you know, comments. I think intelligence is an ill-defined performance metric in the eye of the beholder. It has way too much human exceptionalist baggage associated with it. So I avoid it. And, you know, unless someone I mean, there's a problem with consciousness as well. Unless someone really is clear about what they mean by intelligence or consciousness, you know, it's gobbledygook. It's word salad. You know, you can carefully define these things if you like, but one should. Present AIs are not brain-like, despite all the hype. And, you know, people hype that as a way of increasing their stock prices. Oh, we've got the advanced system that's brain-like, and so therefore it's going to be all powerful and can do everything that a human being can do. We don't understand the signals of the neural systems in animal brains, and connectionist models are, you know, like deep learning models are terrible models of biological brains. They don't even have spikes in them, and they're discrete step systems. They don't have time in them explicitly. And so processing elements don't resemble real neurons. I speak as a neuroscientist who's recorded from real neurons, you know, and there's no backprop evident in the nervous system, and the deep learning analogies are overblown. So I get very impatient with people comparing the weight matrix of an artificial neural network with some sort of response map in some part of cortex. I should say I'm working on non-connectionist architectures that use temporal codes and multiplex signals and signal dynamics, but that's a whole nother thing. The Turing test, imitation games were a big mistake, and I admire Turing enormously for many reasons, but it's a behavioristic test, and it's very shallow. You know, it's whether you can fool a human being into thinking that a machine is a human being. It's very different from reverse engineering brains. From the Turing test, you don't get any insight into how brains work. What are their operating principles? If we reverse engineer brains, we are going to come up with new ways of making devices, new operating principles. And so as a scientist, we need to get off this Turing test imitation game and really start thinking about reverse engineering brains. And some people in the AI community are thinking this way, and have been thinking this way for a long time. But there's a lot of naivete about how similar artificial systems are from biological brains. And just because AI systems can do very impressive things doesn't mean that the way that they do them is anything similar to how our brains do them. You know, they're doing it by brute force, operating on, you know, the entire corpus of human written and spoken language. Machine perception is not unlike biological perception. Convolution nets are getting better because they adaptively choose their input filters, and they can change the input representations away from pixel-based to like Fourier-based and correlation-based and other kinds of things. That's better, but those are not, I mean, it's a long discussion about how and how much these things resemble human and animal nervous systems. There are a lot of major problems with machine vision, mostly owing to the kinds of local features that they're based on. And there are unsolved problems about gestaltist organization, shape perception. You know, what makes a circle of different sizes the same? And how does that differentiate from a triangle, you know, of any color or shape? You can vary it, but you can recognize all those things are triangles. We do that, and animals do that very readily, but AI vision systems don't or haven't. The symbol grounding, again, I'm going to echo some of the things that Fraser said. Most AIs are not in direct contact with the material world. They're operating on symbolic inputs that are removed from the material world, not to say that they don't have some relation to the material world, but the symbols in robotic embedded AIs and brains are grounded, and they're operated, they're embodied and situated in extended PCA systems. Animals and robots are purposive systems. They have multiple goals and goal competition, hierarchies of embedded goals, some more urgent than others. But most AIs have one goal that they're trained on. Cognition is more than just classification. These generative models use large databases of human speech and writing to imitate human conversation without understanding. Just knowing the statistical word associations is not understanding what those words mean. So although that they can imitate and they can do a good job of fooling people that what they're producing is meaningful to those human conversants, the way that they are doing it, their concept systems, if you want to call them that, are very radically different from ours. And there's the problem of the inscrutability of AIs, that even their designers don't know how they work, and that's problematic. And because they're not connected to the world, they also can't go out and make causal models for themselves. So I have one more slide. So, you know, there are enormous promises of any kind of automation, removal of drudge work, more effective human-machine search over the entire data set of human symbolic communications, that we can access that now. We can generate possibilities that were unforeseen by human beings. So it's a really big aid for creativity. We can do better pattern analysis and do all sorts of things. You know, with robotics, better and cheaper elderly care, and more efficient systems of all sorts. However, these systems may not embody the full gamut of human values. They may find local solutions that aren't particularly good in terms of broader human goals. They may seem better than they are because they're inscrutable. There's social disruption because of displacement of human workers. And that's a social problem of how do we distribute desirable work? We need a better distribution of desirable work. The dangers that I see have to do with basically misinformation, manipulation, fraud, and the ability to overload human communication systems, like flooding the zone with crap. And the answer to that is to prosecute fraud. that make it clear when what you're dealing with in terms of a human or an artificial system. And again, the big worries, you know, I come from the generation of the nuclear age, are giving control of autonomous systems that can potentially harm millions of people, like giving them control over nuclear weapons or automated battlefields or agricultural and water life support systems of many humanity. And some people think that, well, you could build moral imperatives into robots like Asimov's 3 laws. But as far as I can see, there's no foolproof, consistent moral rationality. The trolley problem and the incommensurability of deontic versus utilitarian perspectives is unsolved. It's an unsolved problem. There's no way to rationally judge of those. And automated vehicles immediately encounter the trolley problem. You know, if the vehicle is careening in one direction and you've got one person on one direction and 5 in the other, what do you do and how do you decide? So that's all that I have to say. I think that the pop science prep, we need to understand the real limitations and capabilities of these systems. The pop science press needs to sober up, not be so naive, sensationalistic, fear-mongering, and apocalyptic. I don't think that the AI apocalypse is upon us, but it is something we should worry about. Take care.
Thank you, Peter. Who will be the next? Lucille or Eagle? Lucille, you ready?